Hello, viewers. Um, this is Mr. Ayodeji Ogunyeye, and today I'll be discussing independent probability, still on our probability series. Today's topic is independent probability. All right, so let's quickly get to it. Our objective for today's lesson is to understand independency, okay, when you have two events to be independent of each other. And we'll be talking about the use of list of outcomes and the tree diagram. Of course, we shall be discussing the use of the AND rule. The previous lesson, we talked about the OR rule. So in this lesson, we'll be talking about the AND rule. All right, so without wasting time, let's quickly get to it. Now, two events are said to be independent if and only if the occurrence of one event happening has absolutely no effect on the chances of the other happening. Two events, as an example, that we can talk about is the dice and the playing cards. Now, for example, if I throw a dice that lands on 2, it will not affect the chances of my drawing a heart from a pack of cards. They definitely cannot affect each other. They are two separate events that can't affect each other. You can draw a heart from a pack of cards and even throw a 2 on a fair dice without affecting each other. So the two events are said to be independent. All right? Now, what is the probability of rolling a 2 on a fair dice and choosing a heart from a standard pack of cards? Now, you know, in probability, we can write that as P brackets 2 on a dice and a heart from a pack of cards. Now, you can see that that "and" that I have here is capitalized. That means that that word "and" is very important. It shows two independent events. That means one event and another event. But we are now trying to find the probability of the two happening at the same time. Of course, they are not affecting each other. That is why they are called independent events. Now, to find the answer, you could start by drawing an outcomes table. Look at the table right here. This is a list of the types of cards that we have in the pack of playing cards. This is the heart, this is diamond, this is the spade, and this is club. For the dice, these are the numbers that we have on a fair dice, 1, 2, 3, 4, 5, 6. So if you want to do the outcomes, all of these we've discussed before in our previous lessons, all of these that you're looking at are the possible outcomes, okay? Here you have one with heart, one with diamond, one with spade, and one with club. The next row shows 2 and heart. The next one shows 2 and diamond, 2 and spade, 2 and club, and so on like that for the entire possibilities, okay? Now, our focus, all right, if you count everything, you realize that there are 24 different outcomes in total. That means the total number of possible outcomes is 24 as we have it in the table. Our focus is on 2 on a dice and a heart from a pack of cards. So I'm looking for 2 heart, 2 and heart. I'm looking for 2 and heart. So if I take a look at all those possible outcomes, where can I get 2 and heart? I think I have it right here. So which means that this is the only successful outcome of 2 and heart. So I have the probability of 2 and heart to be equal to 1 over 24. I'm sure we all follow through with that. Again, The probability of 2 and heart is actually 1 over 24. But when we need to work out the probability of 2 independent events, both happening, we can use what we call the AND rule. The AND rule. We want to find the probability of each event. Let's do that now. Well, the first one is probability of getting a 2 on a fair dice. Of course, we know that already from previous lessons, that will be 1 over 6. And the probability of getting a heart from a pack of cards is 1 over 4. Guys, you should know that this 1 over 4, I'm sure some of you will be thinking, how did they get 1 over 4 for the probability of getting a heart in a pack of cards? Now, take a look at this, guys. This is the pack of cards that we're talking about. All right? You will see that these are all cards with hearts on them. If you count, you will see that we have 13 hearts all through here, 13 hearts. So since there are 13 hearts and all of the cards inside the pack of cards is 52 in total. Okay, 13 plus 13 plus 13 plus 13, 52 in total. So that means the probability of getting a heart will be 13, because there are 13 hearts, over 52, the total number of possible outcomes, which is the total number of cards in the pack of cards. So therefore, this 1 over 4 was arrived at by simply breaking down the probability, which is supposed to be at the start, 13 divided by 52 is what we are supposed to have for that. But when you reduce it to its lowest, you get 1 over 4. You get 1 over 4. So understand that, guys. Okay. Now, the answer can be found. That means the answer of the probability of 2 and heart. It can be found by simply multiplying together the two fractions. 1 over 6 times 1 over 4 to give you 1 over 24. You can say that that's exactly the same answer with what we got over here. Good one. So in general, guys, the formula for the AND rule is given as the probability of an event A and B is equal to the probability of A times probability of B, where A and B are 2 independent events. Please take note. Where A and B are what? 2 independent events. So this works just for independent events. So if you see the word AND in another type of event, you don't use AND rule. Take note of that. You don't use AND rule, okay? AND rule is used for independent events. Please, let's take note of that. So guys, make sure you take note of this formula that we have here. This particular formula is very important, very, very important. Please put it down. We shall be using that to solve problems on independent events. Moving on. Now here, we can use the tree diagrams when solving questions involving independent probability. Tree diagram. So we are learning the tree diagram now. Look at the way it goes. We are interested in whether we score a 2 on the dice. We have listed a 2 and not a 2, shown as bar 2. I've told you that already in the previous lessons. That is any of the other 5 numbers. Of course, if it is not a 2, it's going to be other 5 numbers on the dice, which is 1, 3, 4, 5, 6. So the probability of getting a 2 is 1 over 6. We know that already. And the probability of not getting a 2 is 5 over 6, which we could have gotten as well from 1 minus 1 over 6. I remember that I explained that in our previous class. Let me just remind you that the probability of an event, okay, the probability of an event not happening, we talked about that in the last class, of an event not happening, if you put a bar on top like that, okay, probability of an event not happening, the bar shows that it's not happening. And we remember that we said that that formula is supposed to be equal to 1 minus the probability that the event will definitely happen. Okay, so that is a quick one, just to remind us. So even if you don't want to think of it that way, you will need to be able to know that if the probability of getting a 2 on a dice is 1/6, then the probability of not getting a 2 is going to be 1 minus 1/6, which is 5/6. Okay. Now, notice that the probabilities also lie on the tree. So we write the probabilities on the tree right here, the way it is written here. You just draw like 2 branches, okay, of the tree. On the first branch, you put the probability of getting a 2. On the second branch, you put the probability of getting, of not getting a 2. You see that the outcomes that we can expect from a dice is either we have a 2 or not a 2. So those are written at the end of the branches. We are now talking about the cards, and this is how it is done, depending on the number of events that you are dealing with. The first 2 branches deals with the first event, which is the dice. The second comes with the card. Now, what normally happens is that you have to draw branches coming out of the first outcome of the dice, okay? For a card, we are looking for a heart on a card. So we must have the probability of getting the heart and not the heart, okay? Heart, not heart. Heart, not heart. This has to happen for both of the 2 branches of the dice. So it's repeated for the 2 branches of the dice. Please take note. The probability of getting a heart in a pack of cards is 1/4. I've explained that. Of course, not a heart will be 1 minus 1/4, which is 3/4, and that is repeated for the second branch of the dice right here. Okay, moving on. Now, the probability of getting a 2 and a heart will now be 1/6 here times 1/4, which is 1/24. Now, why did I choose 1/6 and why did I choose 1/4 here on these 2 branches? It's because this is a 2 and this is a heart from the pack of cards. So 2 from dice, heart from cards. If I was looking for the probability of getting a 2 and not a heart, my answer would have been 1/6 times 3/4. So that is how this tree diagram works. The probabilities of each event as shown are shown. We can now use the AND rule to find the chances. So just like I told you, the probability of 2 and not a heart is 1/6 times 3/4. Okay, you can try the others. I'm sure you know what will happen now. The next one will be probability of not a 2 and a heart. So that should be 5/6 times 1/4. Exactly, which is 5/24. The last one will be probability of what? Not a 2 and then not a heart, which will be 5/6 times 3/4, and which is 15/24. Very interesting. The tree diagram is always very interesting. Moving on. Tree diagrams are a useful way to help calculate probabilities. Use a tree diagram to solve the following problem. 3 cards are to be drawn from a pack of cards. 3 cards, don't forget, we will always draw 3 cards. After each card has been drawn, it is replaced to make a full pack again. So that means that when you pick a card from the pack of cards, you return it before you pick the next one. Remember, we are picking 3. So you pick the first one, you return it back into the pack. Then you pick the second, you return it back into the pack again. Then you pick the third. Okay? Then you pick the third. All right, guys. So that is what we are doing now. And the probability we want to find is probability of drawing 3 spades. You can see the 3 spades here. And the hand is coming up again. And the probability of exactly 2 spades. Now, guys, be careful with this. When we say exactly 2 spades, it means that out of the 3 cards that you have drawn, 2 out of it should be spades. That's what we're talking about. That is what we're talking about. Please take note of that. All right. Let's see how the tree diagram would go. Like I told you, for all the events, card 1, card 2, and card 3. Okay? For card 1, we want to draw a spade. S is representing spade here. So you must tell us the two branches should be probability of spade and not spade. That's how it goes. Spade and not spade. Probability of spade is 1/4, which we got initially by 13 over 52, remember? And not spade would just be 1 minus 1/4, which is 3/4. So you've done that for card 1, you are okay. For card 2, you must do the same thing for each of the branches of card 1. You know we are drawing 3 spades. So card 2 should be spade, not spade, spade, not spade for both branches of card 1. And then you write out your probabilities on the branches like they are written this way. For card 3, the same thing happens. For all the branches of card 2, you must also repeat it like that. So 1/4, 3/4, 1/4, 3/4, 1/4, 3/4, and 1/4, 3/4. I'm sure you understand how that is going. Studied very well. It's quite easy, not that hard. So from what we have drawn now, this is how it works. You can now be able to find the probability of getting the first one to be spade, the second one to be spade, and the third one to be spade. Okay, so probability of drawing 3 spades will then be 1/4, which is this 1/4 for card 1, times 1/4 for card 2, times 1/4 for card 3. And final answer is 1/64. Okay, please take note of that. That is why this goes for pink lines for the branches to show you the direction in which we have taken to pick our probabilities for the solution of probability of S, S, S. Now, guys, take note of this. You need to understand this very quickly. Another way of looking at it, if you can actually be able to think about the outcomes, is without using the tree diagram, is to think of probability of spade, spade, spade as spade and spade and spade. Putting those words "and" will help you to remember that you are supposed to multiply. I'm going to show you that very soon on the board. So, all right, let's move on with that. The next one, for all the other ones, let's try to take a look at them. Although we're talking about the probability of 2 spades, in this case now, that's the next one we need to look at. The probability of 2 spades, exactly 2 spades, remember, means that out of the 3, 2 must be spades. The third one, we don't want it to be spades, but 2 must be spades. That's why I said exactly 2 spades. Remember that. So this is how they look like. These are all the possibilities of having exactly 2 spades. Now, 2 spades can happen in 3 different ways. The non-spade being the first, or the non-spade being the second, or the non-spade being the third. And that's what I've done here. The non-spade is the third here, the non-spade is the second here, the non-spade is the first here, while the remaining 2 should be spades. That is how we get exactly 2 spades when we pick out 3 cards. So if you look at the color here still remains pink, so that is how that one went in the tree diagram. Pink 1/4, pink 1/4 for card 2, pink 1/4, 3/4 rather, for card 3. You know we're talking about spade, spade, not spade. Are you seeing that? Spade, spade, not spade. So that goes for 1/4 times 1/4 times 3/4 for not spade. The next one is spade, not spade, spade. If you look at that, the color here is kind of light blue. So spade, 1/4, not spade, 3/4, and then spade again, 1/4. So 1/4 times 3/4 times 1/4. Last one, not spade, spade, spade. So you come down here for the yellow, not spade, 3/4, times spade in the card 2, 1/4, and then spade again in the card 3, which is 1/4. So you have that here giving 3/64. Finally, we now use the OR rule and add up the fractions. So it simply means that since we know we have 3 different possibilities of having exactly 2 spades, okay, what we are saying in essence is, okay, the ways we can have exactly 2 spades is spade and not spade, or spade, not spade, and spade, or not spade and spade and spade. You can see that I'm stressing the word or to remind you of OR rule. So there's or in between these guys. So the or can then change to plus plus. Let me express that out very quickly. Very quickly. So I expect to have probability of, okay, spade, spade, not spade, excuse me. And then or, so those are the ways we can have, excuse me, or probability of, I'm going to pick it out like that, or probability of, okay. So that is what I'm talking about, guys. So we can then quickly put the not here, not here, okay, and then not here. That will be on the first one now. So you can do your own as not for the first, starting from the beginning, but just make sure that it's not repeated. So is this or this or that? These are the 3 possibilities of getting, exactly 2 spades, exactly 2 spades. And we have done their probabilities here. So the final answer will be 3, this one is 3/64 plus 3/64 plus 3/64. That to give a final answer of 9/64. Very interesting, guys. Very interesting. Okay. If you need to work out the probability of 2 things happening at the same time, you must multiply the individual probabilities together. That's just to explain the AND rule, multiplication rule. Draw a tree diagram, as in some cases, there will be multiple ways of getting the same outcome, just like the last one that we did. All right. Finally, let's take a quick look at this. Twins, James and Rachel, are taking their driving test next week. The probability that James will pass is 0.6. The probability that Rachel will pass is 0.7. James passing and Rachel passing are independent events. Question A, draw and label a tree diagram to show this information. Okay. All right, let's take a look at the other questions. We have to calculate the probability that they both pass. Just one of them passes, neither of them passes. All right, let's get into it now. So this is the first tree diagram for James. You know there are 2 independent events. So the outcomes that we'll pick is pass and not pass. Of course, not pass means failing. So pass, fail, 0.6. Fail will definitely be 0.4. The question actually gave us 0.6 as the probability that James will pass. So you must find the probability that James would fail, which is 1 minus 0.6 as explained before. And that is how we have gotten the 0.4 right here. The next one is to bring the other branches from Rachel. Rachel's probability of passing is 0.7. So probability of Rachel failing is going to be 1 minus 0.7, which is definitely 0.3. So we have pass, fail, 0.7, 0.3, pass, fail, 0.7, 0.0, repeated on the second branch of James. And we've learned how to do that already. So James' test has two outcomes, pass or fail. Rachel's test also has two outcomes, pass or fail. We list this outcome, we list these coming off James' pass and his fail. That means you have to do it coming out of both branches of James. Okay. Now, work out all the probabilities of the combined event one by one. The probability that James passes and Rachel passes, that's P and P. It will be 0.6 times 0.7, which is 0.42. The probability that James passes and Rachel fails, that is P and F. Okay, that's 0.6 times 0.3, 0.18. You can follow through with the others, how it goes, and that is how we get our results right there. So 0.42 is the probability of both passing. The probability of only one passes, only one passes. That means if only one passes, the other must fail. So that means James passes and Rachel fails, or James fails and Rachel passes. So when we say only one passes, don't just pick one person. You have to write out the possibilities. One person, they didn't tell you who the person should be. So there has to be possibilities. So it's either it is James that passes or it is Rachel that passes. And if James passes, Rachel will be failing. So James passes and Rachel fails, or James fails and Rachel passes. Okay, that's for the question they asked us before. So that's why we have to do the addition here. The OR rule takes us to addition. So James passes and Rachel fails is 0.18. James fails and Rachel passes is 0.28. So we add them together to get 0.46. The probability of both of them failing, that is F and F, that was 0.4 times 0.3, which is 0.12 right here. So that is how that goes, guys, with our tree diagrams. I'm going to be explaining a few more examples, yes, in my next video. Please pay attention, make sure you like the video, comment, and subscribe. Very important. And then you shall see me, and I shall see you also in the next video, explaining more examples. Thank you for watching, guys. It has been a wonderful time so far. I'm going to see you in the next class. All right, guys. Bye for now.